Example 14.6, determining sample size. So suppose that you would like to start a quarterly alternative newspaper for Cal Poly students and want to gauge student interest in such a newspaper. Part A, about how many students do you need to survey so that the margin of error for your 95% confidence interval for P, in other words, the proportion of all Cal Poly students who are interested in such a newspaper, is plus or minus 0.1. Well, we're going to use, you're like, well, I don't even know where to start. I don't have a p hat. When we're not given a p hat in this case, we're going to use 0.5 because either they're interested or they're not. 0.5 is the most conservative you can use. It's the most informative. It's kind of the worst case scenario that you're split pretty 50-50. We know the margin of error, we're told, is 0.1. Now we can use that, which is a pretty big margin of error, by the way. 10% is pretty huge. Now I can use the formula and say, okay, what do I know? I know margin of error is 0.1. My Z star is 1.96 because we're looking at that 95% confidence interval. The p hat is 0.5, but we don't know n. Now, you may say, okay, I want to get a sample size, so this shouldn't be too bad. Where students frequently will struggle is, well, how do I get that n out of the denominator? And I'm going to work through this just to make sure that everyone's comfortable. The first thing we're going to do is square both sides. I'm going to write that as 0.5 squared because we've got 0.5 times 0.5. So I square both sides. Notice I'm not going to do any reducing yet. I end up with 0.1 squared equals 1.96 squared. The square gets rid of the square root times 0.5 squared all over n. Now we can multiply both sides by n. Divide by 0.1 squared on both sides to get the n by itself. And when you plug that in, you're going to get 96.04 roughly. Now, we can't sample for hundredths of a student, so we're going to round up to be conservative to give us that extra. So our sample size is 97. So it's a fairly, I mean, it's a decent sample size, but it's, it's fine, but we have this huge margin of error. What if we want to reduce the margin of error? What can we do? Well, one thing we can do is sample more students. You're like, well, how would I see that? Let's suppose that we sample 1,000 students. What will our margin of error be then? Well, based on what we know, oops. As this n goes up, this whole value is going to go down. This ends up being 0.031. So that's quite a bit smaller than 0.1. What if we sampled 1,500 students? I'll leave you to the calculation, but it ends up being 0.025 as the margin of error. What if we do 2,000 students? Well, the margin of error goes down to 0.022. So my margin of error is decreasing. So what do we notice about how sample size affects the margin of error? Well, as n goes up, margin of error goes down. Okay, which makes sense. So you're like, well, wait, should we just get a really huge sample then? No, you want to be careful. Once you get to 1,000, it slows down at how quickly it reduces. So if 1,000's a pretty sweet spot, there's that law of diminishing returns at some point where sampling more and more and more isn't going to get you a big payout, and yet there is cost associated with sampling more. The payout is good going from 10% margin of error with sampling 97 to going to 1,000 where we get our margin of error down to 0.031. But much further, it's not great. Even by taking 50% more students, we got a very small reduction in our margin of error.